let's see what happens. What happens when you take a hose here and you want to wash your car, you put a nozzle on it at the end and the water comes out of the nozzle here. You'll notice the water coming out of the nozzle is going to be faster, moving faster. It shoots harder there. If you try to power wash your house, you probably, and by mistake you run that water under your foot or your toe, you'll know the feeling there. It hurts like hell because the water is moving out high speed. So why is that? I'm going to enlarge that picture just so I can write stuff in it. So if you have that section and you're going to shrink it now to this section, to a smaller one. So the water is coming through this. It's going to be moving through that. Through this, let's call, actually has a velocity v1. Through this, it's going to have a velocity v2. And let's call the area here area 1. If it's a circle, pi r squared. R is bigger here. The area we called A2. Again, if it looks like a circle, pi r squared. Smaller r. When you open the faucet, that water comes out of the faucet. Unless you have a leak in it, the amount of water, the volume of water going through this should equal the volume of water going through that one. So the volume, the change in volume here should be the same as change in volume in this one. Because the water comes in, whatever comes in must leave. Otherwise, if more stuff coming in than leaving, you're going to see that hose start to expand, that hose. Get bigger and bigger and bigger, then it's going to pop. Well, if the hose doesn't expand, that means what goes in must come out. Well, the amount of water going through it, the change in volume is equal to, for area 1, times V1 times the time. And the change of volume in this is area 2 times velocity 2 times the time. Well, it has to be the same time. The amount of water in the same time, what goes in 1 second has to equal what leaves in the same amount of time. So I can actually drop out that delta T, but I'm going to leave it for now here. Now, mass is what? Rho times volume. Change in mass, rho doesn't change, times the change in volume. So now let's look at this. Change in mass 1. The water through this end, it's rho, or rho 1 if it's actually different. If you have different liquid, you could have a hose with different liquid in it, water, and it was filled with oil. You want to push it out. So let's make just in general there. And since volume 1 is equal to A1, velocity 1, delta T, change in mass 2 is going to equal rho 2 times the change in volume 2. And change in volume 2 is going to be rho 2 times area 2, V2, delta T. Since these are equal to each other, the change in the amount in 1 should equal the change in 2. So I'm going to have rho 1, area 1, V1, delta T equals rho 2, area 2, V2, delta T. Notice delta T is the same on both sides. I can just drop it. So the equation rho 1, area 1, velocity 1 should equal rho 2, area 2, velocity 2. Now again, I'm making the assumption you could have more than one liquid, one fluid inside that tube. if you only have one fluid. If you only have one fluid, that rho is going to be the same for both of them. So you'll have what? Area 1, volume 1 equals area 2, volume 2. And that's the equation of continuity. This is really the equation of continuity. But if you're only having one fluid, like everything is water, everything is oil, everything is the same fluid, then rho 1 will equal rho 2, and you end up with that equation. Usually when you attach your hose to the faucet, there's only water going through it. For a few seconds, there's water and air. The hose is empty, right? Has air in it. You get the water coming, you're pushing the air out. So rho 1, rho 2 will be different. But once that water fills the hose, you only have water in it, and rho 1 equals rho 2, and this becomes that equation. So what happens with that water sprayer there? Let's see what happens when you want to wash your car. You have a hose which has a diameter of 9.6 centimeters. This is D1. And it's moving at a speed, it's not going that fast inside that, speed of 1.3 meters per second, velocity 1. It's going to go through a nozzle, tiny nozzle at the end here. And the diameter for that nozzle is 2.5 centimeters. And what is the velocity coming out of it here? We're assuming this hose has only water in it there. The equations area 1, velocity 1 should equal area 2, velocity 2. That's the equation of continuity. Area 1 is pi r1 squared times v1 equals area 2, which is pi r2 squared times velocity 2. Since pi shows up on both sides, I can just drop it mathematically. I don't need it. R1 is what? What's half of 9.6? 4.8. You can leave it in centimeter if you want to, or 0.048. Times 1.3 equals R2, which is 1.25.0125 squared times V2. Can we get what V2 equals to? So the velocity of the water coming out is 19.2 meters per second. It goes in at 1.3, it comes out at 19.2. This is called the equation of continuity. Area 1 V1 equals area 2 V2. Again, if you want to be general, rho 1 area 1 V1 equals rho 2 area 2 V2. Equation of continuity. Again, we use the top one if we have the same rho, the same fluid, the same thing in the hose. If you have different things, we use this one. Now what happens if you take a hose now, you take it to the roof, you want to wash the windows? That changes everything. Changes the height there. We need to come up with an equation that will deal with that. And that's Bernoulli's equation.